Okay, let's have a look at this one. This is from the IGCSE question 2.7, exercise 2.7. So the IGCSE. It's 2.7, and this is the year 11 or year 10 accelerate classes. And we're looking at limits of accuracy. And the question says a mass of a cube of side 2 centimeters is given as 100 grams. The side is accurate to the nearest millimeter, and the mass accurate to the nearest gram. It says calculate the maximum and minimum possible values of the density, crikey, of the material. And the density is given by, and that's the nice thing here, it's actually got an equation for it. Density is mass divided by volume. All right, so we could probably actually do this on the side here. I'll try and do it here. So we've got, first of all, we've got a cube. Here's my cube, roughly drawn. Oh gosh, it's very roughly drawn. Okay, and it's each side is 2 centimeters, so 2, 2, and 2. I won't bother putting the units in at this time. And we know it's 100 grams, so the mass of this is equal to 100. I'll put grams there. Actually, I will put centimeters. Here we go. So we know the R centimeters. Fantastic. All centimeters. Okay. And we've got to calculate to the nearest, these are going to be to the nearest millimeter, and these are going to be the nearest gram. So whenever we're going to find the maximum possible values, this is nice and straightforward. We just take the 2. Here's our 2 centimeters. Now we know that we're going to extend this out from one point to another point here. And we know that the points here are going to be reflective of what it says as the minimum unit, or accurate to the nearest millimeter. Now, a millimeter, first of all, is 0.1 centimeters. Yeah? So I'll put 1 millimeter. And all we do is we're going to divide this by 2. So half a millimeter, so 1/2 of 1 millimeter is 0.05. There it is. So it's going to be accurate to 0.05 centimeters. So what we're going to do is to add 0.05 centimeters onto this and take 0.05 centimeters off this. So this is going to be 2.05, and this is going to be 1.95. There we are. So these is now the maximum it can be, and this is the minimum it can be, and it can't actually ever get to that. It could be everything but that. If this was a number line, then we'd write the number line like this, and over here like this. So it includes this, and all the way up to here, almost to the point it gets to 2.05, but it doesn't actually include that value. All right, now let's do so that's this taken care of. So you've got a maximum possible this can be, if it's going to be the nearest millimeter. Now we've got, and this is the minimum. So we've now got grams. Now the grams were to the nearest, what was the next one? It's the nearest gram. A gram, well, a gram is, nearest gram. Nearest 1 gram. Okay, so 1 gram, so if we took 1 gram, and we divided it by 2, we'd get 0.5 grams. So that's going to be the minimum. So the grams now, in terms of the mass of this thing, it's going to be 100 grams, but it's going to have a maximum minimum from this point to this point here. And the maximum is going to be this plus this, which is going to be 100 plus that. This is going to be that minus that, which is going to be 99.5. There we go. So now we've got this stuff here. It's all sorted out. We can now throw it into the equation. Now we've got to be a little bit careful here. First of all, I think we should find what the actual volume of this thing is, because its density is mass divided by volume, and volume is going to be this cubed. So we're going to have 2 outcomes here, and we're going to have an upper and a lower. Now to find the upper, and this is the important thing, whenever we're finding, because we've got mass, I'm going to write this out actually, we've got density is equal to mass over volume. Now if we want the maximum density, the maximum bound, or if you like the upper density, upper density, I'll put upper den equals, then what we're going to use is we're going to use the maximum mass and the smallest volume. So it's going to be the maximum mass, so put the mass upper, and the volume will be lower. And of course, the lower, and this, by the way, is the trend we have to use, the lower density is going to be the mass lower divided by the volume upper. So let's see how that plays out. So first of all, let's go upper. So the upper density is equal to the mass upper. Well, mass upper is going to be 100.5. There it is. So it's going to be 100.5. And that's going to be divided by the volume lower. What was the lower volume? Well, volume, the lowest possible thing it could be is 1.95. And of course, it's volume and it's a cube, so it's going to be 1.95 cubed. So let's see what that would come to. Here we go. Here's a calculator. I'll just quickly throw that in now. And we're going to have 100.5 divided by, and we're going to have 1.95 cubed. There we go. And we get 13.5555555. So I'm just going to call that 13.55. We'll go with 13.5538. Let's write that in first of all. 13.5538. That'll do for now, okay? We won't worry about the units. Let's do the lower now. And then we'll have a look and see what was the accuracy they wanted it. The lower density, again, excuse my very rough writing here, and it's very, very small. So we're going to use the maximum, the mass is going to be the lower. Well, the lower is going to be 99.5. There it is, 99.5. And it's going to be divided by the upper volume, which is 2.05 cubed, which is 2.05 cubed. And this thing we're doing now is actually a trend of all things where division is involved. Of course, if this was just an area, like you've got an area like this, and you were wanting to find the maximum, well, you take the upper of this and multiply it by the upper of this. Or let's say it was this one here, we're going to look for lower. It will be the lower of this times the lower of this, or the lower of this times the lower of this. But here you have to sort of cross them over. All right, so let's have a look what this one would be. So it's 99, here it is. So it's 99.5 divided by, divide by, let's have a look, 2.05, and it's cubed. Oops, oh, what did I do wrong? Let's look. I've got a comma in there. What's that doing there? That was weird. All right, that's better. 11.549. 11.549. Let's write that in. 11.549. All right. So what we're wanting here now, I think, and let's have a look here. I've actually got the answers. Actually, I pulled the answers out here. Here we go. Oh, that's right. I'm going to put the units as well. Trust me. All right. So, well, first of all, we get the numbers right. So the upper density here is 13.5538. What did they get? Upper is 13.6. So they're just setting it to 1. Oh, it's 1 dp they want it to. Okay, they want it to 1 dp. So 1 dps would be 13.6. And you can put in the units as well, which is grams, of course, per cubic centimetre. Grams per cubic centimetre. And I'm going to write to the negative 3 here. I think that's probably, wait, be grams per cubic. It is cubic, of course it is, yeah. And so this one here, same deal, but they want it to 1 dp. So this is just going to be 11.5, and that's going to be, again, grams per cubic centimetre, grams per cubic centimetre. And I would just go ahead and write it like that. So they're my two answers, and that's how I get them. Hopefully that makes sense.